Hello again. Welcome to our next week of Python. So this week we're going to get into some slightly more advanced stuff. Nothing too crazy, but last week you did some things with variables. You got input from users. You draw some pictures with the turtle, which I bet you did not expect to be able to say about a class like 488. And that's all cool. And it's useful, and it's the basic it's the base things that you learn in any programming language. But this week we're going to get a little bit more advanced, a little bit more interactive, so you can do some other cool things. So first we're going to start off with what we call if-else statements. So before we can get to if-else statements, I need to take a step back and talk about what a Boolean statement is. But basically, a Boolean statement is a statement, or in this case, a bit of code, that can be resolved into being true or false. So they're used in if-else statements to determine what part of the code should run. So last week I said, code always starts at the beginning and then goes bing, 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 and it runs every line of code until the end. That was a slight lie. Because what you can do here is you can say, like, okay, well, if this condition, then do this. Or if something else, do something else, whatever. So you can set your code up so that depending on what information is in your program, it will do slightly different things. It's still starting at the top and then going down, but it won't necessarily execute every line of code. You'll see what I mean in a second. But, think about it in real life, right? If you're like, oh, okay, if it's raining, I'll bring an umbrella, otherwise I won't. You don't bring an umbrella anyway, right? You're not executing the line of code that says, like, well, I'll bring an umbrella if it's not raining. Coding it's basically like that, just, more spelled out. So, in order to create a Boolean statement, you have comparison operators. So, the first four should not be surprising. They should look pretty normal, right? Less than or equal to, greater than or equal to. And I have some examples over here. These are going to seem really, really obvious because I'm using numbers where these are always going to be true, right? So it is true that 17 is less than 18. Please don't be surprised by this. It is true that 17 is less than or equal to 18. It is also true that 18 is less than or equal to 18 because 18 is equal to 18. Greater than or equal to, same principles. The things that you have not seen before, at least probably, are the equals and not equals. So this is really important. If you remember nothing else from this slide, try and remember this slide, but this part's really, really important. If you want to compare two things, to check to see if they are equal, you have to say equal, equal. You have to have those two equal signs. If you only have one equal sign, then you're assigning a value to a variable, right? Because we did that last time. All right, name equals whatever, age equals whatever. Only one equal sign means that you are assigning. Two equal signs means that you're comparing. So for example, 20 equal 20, or here I have red equal red. Those are both true statements because they are the same. Not equal is actually pretty cool. So if you've ever seen on the internet something where someone's like exclamation point equal, it comes from programming. So it reads as not equal to. So 21 not equal to 20, and red with a lowercase r is not equal to red with a capital R. That is also true. So just keep in mind that Python is extremely, extremely literal when comparing strings. They have to be exactly the same. There's no room for, oh, of course you meant things. So, example, here I have 5 less than 6, that is a true statement, 6 greater than 9 is a false statement, and again, red equal capital R red is false. A little bit more, you won't necessarily need to use this, but it's just good to know. So you can use Boolean operators to combine Boolean statements, so A or B. So I could say 5 less than 6 or 8 greater than 12. One of those is true, right? So A or B. A and B is, they both need to be true for the statement to be true, and then not A basically negates A. If this is just giving you flashbacks to some class where you learned about logic proofs, it should be. This is exactly where they all come from the same place, logical operators. So, truth table, oh my god. Again, You do not have to use these for the assignment for this week. I just wanted to show them to you in case you found that you did want to do some slightly more complicated programming, because some people, but if you remember, A or B, if either of them is true, the entire statement is true. A and B, they both have to be true for the entire statement to be true. So just a quick refresher to some basic logic concepts. All right, so an if-else statement though, right? So we have the idea of a Boolean statement, which is some kind of comparison where you can evaluate it into being true or false. So we use the statement to test truth conditions and then run the code associated with the if or the else or whatever. So here I have a short example. So I'm saying age equals int input. How old are you? So remember, this goes way back to when I was talking about input and converting types, because in the if statement, I want to check to see if the age is less than 18. The age has to be an integer. If I try and compare the string, so quote 18 unquote, to the number 18, I'm going to get an answer that does not make sense. Here I'm asking for the age, and I'm turning whatever they type into an int. And I say, if age is less than 18, then I will print too young to vote. Otherwise, so that else statement, I will print you can vote. You know, code starts at the top and goes down, but you're not necessarily going to execute every line of code. So here you're going to start with age, you're going to get the input, and then you're going to check to see if age is less than 18. If it is, then you'll print too young to vote, and then you skip the rest of the code. If the first condition is met, then you just ignore everything else in this set of if-else statements, because you don't care about the rest of it. You've met a condition and you move on with your life. That is all. And then if it's 18 or greater, then you skip this print statement, you skip the part that says too young to vote, and you go straight to the else and the print you can vote. So code is still executing sequentially, but we're skipping a few things. You can have more than one condition that you're checking for. So for example, here I'm saying, all right, this time I'm going to do something with strings, so I don't need to convert to an integer or float or anything. So I'm going to say color equals input, and I'm going to ask, what is your favorite color? And basically, if the person says blue, so I'm using equal equal, that is really important, do not forget two equal signs for comparison, then I will print like this guy, and then I have elif. Oh, alright. So basically what this does is this means that this whole block of code kind of goes together as a unit. So you've got if, elif, and then else. And you can actually have multiple elif statements. So the first statement always has to be if, and then you can have a bunch of elif statements if you want. And then at the end you have the else. Else's are actually optional. You don't have to have a default, but a lot of times you want one, so that's okay. So elif color equal green or color equal brown. So if they typed in green or brown, then it'll print like the trees. This is not amazing code, it's just something that fits on the slide and that kind of makes sense. And then if they type something else, you just say, oh, how nice. I mentioned this in previous lectures. I just want to reiterate, I am not asking you to be able to sit down and just write this kind of code from scratch, from your head, from memory. What I am expecting you to be able to do for this class is to take a look at code that I've given you and make a couple modifications to it. So we're not going to ask you to write some crazy thing that is so far removed from code that I'm showing you that it's going to be really hard to deal with. We're really just saying, like, look, we showed you something. Can you modify it a little bit to do something else that's kind of similar? So if this feels complicated, don't worry, because we're not going to do anything like really, really crazy with this, right? This is only a 2-week introduction to Python. So we're just trying to give you kind of a broad sense of how programming works. The only problem is that in order to get any kind of sense of how programming works is you kind of have to get into the nitty-gritty details of things like syntax. Speaking of syntax, let's take a closer look at exactly how an if-else statement looks. So, you must end each if, elif, else line with a colon. So you'll see back in this code I have if color equal blue in quotes and then a colon. Each of these has a colon. The colon is Python's way of saying, okay, or it's the way to let Python know that, okay, something is coming next that is kind of dependent on what came before. You'll also notice that if and elif lines must have a Boolean statement to go with them, right? So here I'm saying if color equal blue, or I'm saying elif, it's green or brown, but else doesn't have a Boolean statement. Else is just the default, it's the catch-all. Okay, finally, any code that you want to run when a condition is true has to be indented. So you need that colon, and then you also need to, I usually hit tab in idle. That'll automatically indent a certain number of spaces, which is just nice and a default way of doing things. So it will indent. So if color equal blue, colon, new line, indent, print like the sky. And in fact, if I wanted to print something else, you know, like print like the sky, and then on the next line print or the ocean, I could do that. I just have to make sure that print line was also indented and lined up with the one about the sky. So Python uses indentation to kind of group things together. So just something to keep in mind. In fact, I think in idle, if you hit colon and then hit enter, it will automatically indent. So if it doesn't, you might need to hit tab, but it will actually probably automatically do it for you. And then on the next line, when you go to type an elif or an else or whatever, you have to hit backspace to get back to the beginning of the line. So just something to be aware of. Python is very sensitive to how things are indented, and you'll want to keep an eye on that. Once again, for the practice, I want you to type out the code from these slides into a new fresh Python file that you are going to save and comment, and make sure that you can get everything to run. You know, and feel free to play around with it, you know, so maybe take the code from the slide with what is your favorite color and change it so instead you ask the user what is their favorite fruit, and you make some comments about, you know, fruit or whatever. See if you can modify the code. That will help you get a sense of how all this stuff kind of plays, you know, pulls together and works, and it'll give you a leg up on the homework for this week. All right, so as always, have fun, and I will see you in the next lecture.